Yes, hi guys. So I was doing question number 5. Okay, now fifth question or question number 5. I was doing. Let me just continue from there. Now here we are talking about addition and multiplication of matrices. All right. Now in case of matrices, as I've discussed about what are the properties of addition and multiplication. Here in question number 6 also properties of multiplication I'll discuss about again. Okay, and as I've discussed already, that what is the addition and multiplication of matrices. In case of addition, both the matrices must be of the same order, only then we can add them, okay, or subtract them. One matrix can be subtracted from another one if both are of the same order. They are known as commutative. Okay, and now in case of multiplication, if two matrices are of the required order, what is the required order I've talked about, then they are known as, they are conformable. Okay, both matrices here are conformable or not conformable. Conformable. Okay, conformable. So both matrices A and B are here conformable. Then AB will be calculated, or BA is not calculated. Let me check it whether AB is equal to BA or not. Let me okay, I'll discuss it again. I just calculated A into B. The same the method I've discussed number of times. Let me again talk about that. Now here A and B are, if they are multiplicative, what is that? If they are conformable, then what is the required thing? That both matrices, matrix A, if we have to require, we have to find multiplication of A into B. That means AB. For AB, the number of columns of A must be equal to number of rows of B. Then A and B are conformable or conformable. All right. If B number of columns of B, first whatever we are multiplying, the first matrix number of columns and second matrix number of rows must be equal of the same order. Only then they are conformable. Then we can multiply them. In this case, we were discussing about. Let me continue again, for there was some disturbance in between. So I just continue this again. I'm continuing. Okay, there was disturbance from outside. So I just stop it. Now let me continue it again. So I was multiplying A and B. Okay. So A into B, let me write here. This is solution we are finding out. Solution. Okay. So here, whether A and B are confirmed, let me check it. Here A, let me write here. Here A, sorry. Here matrix A has how many columns? Here columns are 3 columns. 1, 2, 3. 3 rows and 3 columns. It's a square matrix, undoubtedly. Has 3 columns. Has 3 columns. Has 3 columns. Okay, and B matrix B has 3 rows. Why 3 rows? 1, 2, 3. 3 rows. Has 3 rows. They are conformable. Hence they are conformable. They are conformable. That means they can be multiplied. Multiplication is possible. Multiplication of these two matrices A and B is possible. All right, so they are known as conformable. Now let me multiply them. And what is multiplication? The process I have talked about. That here AB, let me first write A. This is 1, 0, 2. Okay, 1, 2, 1. This is 2, 3, and 1. Into multiply 2. This is 1, 2, 3, 2. This is 4, 3. Okay, both are multiplied. Now, in case of multiplication, as I have discussed already, that when what we multiply, we take first row, multiply correspondingly to the every element of the first row, first column. Okay, then the first element of first row is calculated. For that, what we do? We multiply them correspondingly, add them, total addition. Whatever addition of that total addition comes out, that is one element. Okay, so corresponding multiplication of first row to first column, and then to second column, second element is calculated. Let me first multiply first row, let me write here, this is first row 1 0 2. Let me write in between, this is 1 0 2 first row, and column is this first column 1 3 and 4. So we multiply them correspondingly and add them. 1 into 1, this is 1 into 1 plus sign, 0 into 3 plus sign, 2 into 4. This is one element. Addition of this will be 1 into 1 is 1, 0 plus 0 into 3 is 0, plus 4 into 2 is 8. So this is 9. The first element comes out to be 9. So first row, first column, first element of the required, multiplicative, or whatever the product comes out to be, that matrix will have the first element as 9. So this is the product of these two elements. Suppose this AB is equal to C. C is the matrix here. Let me take this is C. AB is equal to, let me take C. So C matrix will have the first element. Now first row, second column. Now first row, we have to write here second column. For the second column, this is, let me multiply corresponding multiplication again, and then add them elements correspondingly. 1 into 2, this is 1 into 2, 0 into 2, plus 0 into 2, plus 2 into 3, 2 into 3. Now addition of this whole. So first row, first column will give us first element after adding all those multiplications. Okay, and then first row, second column, corresponding multiplication, and then add them. So this 1 into 2, 0 into 2, 2 into 3 will give us, this is 2 here, plus 0, 2 into 0, 0, plus 2 into 3, 6. So this is 8. Second element of the product matrix is the matrix which is obtained after multiplication of these two matrices is having these two elements. So first row multiplied to first column, then second column correspondingly, and will give us two elements here. Similarly, let me now multiply the second row. Second row is 1 2 1. This is second row. Again multiplied to first column. First column is 1 3 4. In this way, simply we can multiply them. So this multiplication 1 first row, second row into first column. The second row 1 2 1 into first column is 1 3 4, multiplying correspondingly. So 1 into 1. This is equal to 1 into 1 plus 2 into 3 plus 1 into 4. This is corresponding multiplication. Will give us, this is 1 plus 3 to the 6 plus 4. This is 11. For this 6 plus 4 10, 10 plus 1 11. So the first element of second row is 11 of the required product matrix. So the matrix obtained after multiplication of these two matrices will have this first row of first element of second row. This is let me take R21. Okay, so R21 element is 11. This is 11. Now second column. What is second column here? 2 2 3. This is 2 2 3. 2 3 here. It will give us again corresponding multiplication 1 into 2 plus 2 into 2 plus 1 into 3 will give us 2 plus 4 plus 3, 7 plus 2 9. Again 9. It is 9. So second row is now complete of the product matrix. It will have second row as 11 and 9. Now again the third row. Third row is 2 3 1. 2 3 1. The third row of first matrix is 2 3 1. To obtain the elemental third row of the product matrix, we have to multiply corresponding again. This is second, or we could find out second. Now first, let me find out first. This is 1 3 4. First column of the second means B matrix. B matrix first column multiplying to the third row. Third row, first column multiplication. And again corresponding multiplication. This is 2 into 1 plus 3 into 3 plus 1 into 4. This is just like systematic method. This 2 plus 9 plus 4, 9 plus 4, 13 plus 2, 15. 15. So first element of third row is 15. This is 15 here. Okay. Now the second column. Let me write here second column. This is 2, 2, 3 of B matrix. B matrix is having second row, sorry, second column now, and third row. Third row multiplied with second column will give us the second element of third row of the product matrix. Okay, now this will give us, again, this is 2 into 2, 2 into 2, plus 3 into 2, plus 1 into 3. It is giving us, let me write, this is 4, 3 to the 6, plus 3, 9 plus 4, 13. It is 13 here, it is 13. So this is the, okay, product matrix of product of AB. AB product is possible here. This is the answer here. Okay, so just let me write here. This multiplication is equal to multiplication or product matrix is 9, 8, and this is 11 and 9. This is 15 and 13. This is the first answer, AB. AB is calculated. Okay, so AB is possible. Now, so AB is possible. AB is possible because for that both matrices A and B are conformable. They are conformable. AB is possible. This is the answer here. Answer of the product matrix is this: 9, 8, 11, 9, 15, 13. Okay, now this is the first answer. Now what about second? It says find BA also. Is BA possible? Are B and A conformable? Let me check it. If they are not conformable, then we say that multiplication is not possible. BA will not be possible. Okay, so what is the possibility here? Here, B matrix. Okay, here B matrix has how many columns? 2 columns. Number of columns has 2 columns. These 2 columns here, first column, second column. So BA, to find BA, multiplication of B into A, or matrix, 2 matrices B and A. If I multiply BA, then for BA it is required that number of columns of B must be equal to number of rows of A. Well, now let me check it whether they are equal. So this is B matrix has 2 columns. Number of columns of B is 2 here, 2 columns. What is the number of rows of A, and number of rows of A is, what is that? Is 3, where it is a square matrix, 3 rows and 3 columns here. It is 3 by 3 matrix, and it is 3 by 2 matrix. 3 by 2. So AB by possible because number of columns is equal to number of rows, but number of columns of B, which is 2 here, is not equal to number of rows of A. BA is not possible. B and A, BA is not possible. Is not possible. BA multiplication is not possible as they are not conformable. They are not conformable for multiplication. They are not conformable for multiplication. Matrix multiplication. Let me write here matrix multiplication. They are not conformable for matrix multiplication. So what is that? BA is not possible. But we cannot multiply B to A. AB is possible as we calculated, but BA is not possible there because B and A are not conformable. Number of columns of B is not equal to number of rows of A because number of columns of B is 2. Number of rows of A is 3. So they are not equal. 2 is not equal to 3. They are not conformable. BA is not possible. Alright. So this is the second answer here. This is the answer second. So BA is not possible. Here AB not equal to BA, as I told you about. BA is not possible, so AB is possible. So AB is not equal to BA. Even if that is possible, AB will not be equal to BA because multiplication is not commutative. Okay, now let me talk about question number 6. What is the question number 6 now? Let me now talk about question number 6. What does it say? Question number 6 or question number 6 here. What is question number 6 or 6th question? Let me now talk about. Question number 6 says, what is the properties of matrix multiplication? This I have talked about in the beginning, but let me again write those 5 properties of matrix multiplication. What are the properties of? Let me write here properties of matrix multiplication. Matrix multiplication. Properties of matrix multiplication. First property is matrix multiplication. Matrix multiplication is not commutative. Is not commutative. Is not commutative. What does it mean? That is, AB is not equal to BA. Even if AB and BA are conformable, but the result will not be same. So AB is not equal to BA. This is commutative. I mean, this is commutative law. That if AB is equal to BA, then it's commutative law follows. If AB is not equal to BA, that means commutative law doesn't follow. So in case of multiplicative, okay, let me take two illustrations, easy illustration. Let A be equal to, let me prove this. This is the first proof here. This is the first property of multiplication. Let A is equal to 2 by 2 matrix. Let me take this is 3, 2, this is 4, 5, no problem. And B, let me take this is 1, 2, this is 2, 3. Both are 2 by 2 matrix. 2 by 2 matrix, where matrices both are. So multiplication is possible because number of columns of A is equal to number of rows of B. Even number of columns of B is equal to number of rows of matrix A. So BA is also possible, AB is also possible. Means they are conformable for multiplication. But let me check whether AB is equal to B or not. Let me check it. So first find AB. So let me write here A and B both are conformable for multiplication. Here A and B both are conformable for multiplication. Alright, both are conformable for multiplication. That is, AB is possible and BA is also possible. That is, AB is possible and BA is also possible. BA is also possible. Means both are conformable. Both multiplication are conformable. Means multiplication is possible. We can multiply them. But what is the result of them? Whether they are equal, let me check it. So that must not be equal because that is the rule says that commutation law doesn't follow for multiplication. Matrix multiplication. Okay, so both, well, number of columns, if I find A, B, the number of rows, number of columns of A must be equal to number of rows of B. 2 equal to 2. So multiplication of AB is possible. AB, let me find AB now. AB, let me write them both. This 3, 2, 4, 5, multiply 2, 1, 2, 3. Let me find the result of this. Now corresponding multiplication again, first row, first column, it is 3 into 1, let me write complete, plus 2 into 2, this is 2 into 2. Corresponding multiplication 3 into 1, 2 into 2. It is first column, second column. Okay, now second row multiplied 2. Sorry, this is first one. First row multiplied to second column that are not done yet. This is 3 into 2, 3 into 2, 2 into 3 plus 2 into 3. Okay, now second row first column. Second row to first column, 4 into 1 plus 5 into 2. Okay, again second row to multiply to the second column. Okay, so this is 4 into 2 plus 5 into 3. So that's 5 into 3. 4 into 2, 5 into 3 plus. Now the resultant of this resultant matrix will be 3 into 1 is 3, plus 2 to the 4, alright, 3 to the 6, plus 3 to the 6 again. This is 4 1 is 4, plus 5 to the 10, this is 8, 4 to the 8, 5 to the 15, total addition will be 3 plus 4 is 7, alright, 6 plus 6 12, second element of first row is 12, and this is 4 plus 14, 4 plus 10 14, 8 plus 15 is 23. These are the elements of the resultant matrix of AB. AB is this. Now let me first multiply. Let me find BA. Okay, so what is the BA then? Let me check it. So BA, now find out. Now BA. B into A. It's going to first write B. So this is B matrix. 1 into 2. 1, 2 and 2, 3. Okay. This is now A matrix. A matrix is 3, 2, 4, 5. Multiplication is possible because BA is also B and A both are confirmable for multiplication. So number of columns of B is equal to number of rows of A. So this multiplication is possible. Let me check it. For the final answer, let me multiply. So first row, first column, corresponding multiplication. This is 1 into 3 plus 2 into 4. 2 into 4. This is first element. First row, second column, and this is 1 into 2. Okay, 1 into 2 is not AB is not equal to BA, that we have to prove. So 1 into 1 and 2 multiplied to second column is 1 into 2, 2 into 5. Multiplication is possible, but AB is not equal to BA. So multiplicative matrix of matrix multiplication is not commutative, that we are going to prove, because here the element is 4 plus 4 into 2 8, 8 plus 3 11. Here 11 is not coming. First element is 7 there. This is different. Okay, so BA is coming different matrix. Okay, now second row, first column. So second row and first column, 2 into 3 plus 3 into 4. Again, second row, second column. This is 2 into 2 plus 3 into 5 plus 3 into 5. Okay, so this is giving us 1 into 3 is 3 plus 8, 2 into 1 2 plus 5 to 10, this is 12 here. Okay, now this is 2 3 is 6, right, plus 7. This is 4 here, this is plus 15. Now resultant matrix here BA is 11, 2 plus 10 is 12, alright, 6 plus 7 13, and this is 4 plus 15 19. It is altogether different. So BA is not equal to AB. It's proved. So the resultant matrix here was 7, AB was 7 12, 14 23, here 11 12, 12, one element 12 is okay equal. Second element of first row, is equal, but other three elements are different. So even if single element is different, one element is different of any two matrices, this is different. So AB is not equal to BA, we have proved. So AB is not equal to BA, hence proved. So any illustration can be taken, any I mean, numerical values can be taken, but they must be confirmed. Confirming means multiplication of AB and BA must be possible, but is not equal. AB is not equal to B, hence proved. Hence, AB is not equal to BA. This is the first property of multiplication, matrix multiplication. Now, second property. Let me talk about property number 2. For the second property, I'm taking here numerical illustrations. Otherwise, algebraically, I could prove that, but that is not clear to the student. First, let me clarify with the help of illustrative. Examples. Illustrative examples. If I take, let me take now second associative law. Okay, so matrix. Matrix multiplication is associative. Okay, follows associative law. Associative law. If A, B, and C are conformable for multiplication. What does it mean? Let me just write it as multiplication. Are conformable for multiplication, that means A, BC, let me take A into BC is equal to AB into C. First we multiply either AB first, then C, or first BC, then A first. Okay, A into BC. So BC we multiply, then we multiply to A, whether they are equal. But they must be conformable for multiplication. What does it mean? That means order of column and rows and that must be equal. Otherwise, they are not conformable. So let me take A, B, C. All three are square matrices. Simple example or simple illustration here. Let me prove it. So this is proof here or solution. If A, B, and C are conformable for multiplication, what do you mean? Are conformable for, or their conformability is assured that A, B, C can be multiplied together. I mean, all the three are multiplied together. That means their multiplication is assured. Multiplication or conformability is assured. Conformability is assured, only then it is possible. For multiplication, that means assurance of conformability must be there, otherwise is not possible or cannot be proved like this. So in multiplication, A, B, and C are conformable for multiplication, or is assured. Conformability is assured. If conformability is assured, only then this is possible. So let me take one illustration here. Simple illustration. What is that? That A, B, and C. A, B, and C. All three are square matrices. Let me take square matrices. Okay, let's simple illustration here. Let me take this is 1, 2, 3, 4. Okay, this is first square matrix, 2 by 2 matrix, and B also let me take 2 by 2 matrix with square matrix. B is 3, 0, 1, 2. Okay, and C is also a square matrix. This is a square matrix here, 2 by 2 of order 2 by 2. So, or of order 2 square matrix. If we just say of order 2 square means number of rows, columns, and are equal. Number of rows equal to number of columns. That means that is a square matrix. You know. Okay, this is from definition. Now C is also a square matrix. We take that 1, 1, 3, 2. This is your C. Let me write them here and then prove that AB equal to BC. So let me write here these three matrices. Here A, B have taken as, okay, 1, 2, 3, 4. 1 2 3 4, and B is equal to B is equal to 3 0 1 2, and C is equal to 1 1 3 2. Okay, now let me find AB and BC. First AB and BC, and then we will multiply to other element. First let me find out what is AB. This is AB. So AB means this is 1 2 3 4 A. B is here 3 0, and this is 1 and 2. Okay, this is AB here. So AB, let me multiply first row, first column, then second column. 1 into 3 plus 2 into 1, first element. Then first row, second column. 1 into 0 plus 2 into 2. Again, second row, first column. This is 3 into 3 plus 4 into 1, corresponding multiplication. This is 4 into 1. Again, second row, second column. This is 3 into 0 plus 4 into 2. 4 into 2. This will give us 3 plus 2, 5. This is 0 plus 4. This is 9 plus 4. This is 0 plus 8. It will give us AB as 3 plus 2, 5. This is 4. 0 plus 4 is 4. 9 plus 4, 13. And 0 plus 8 is 8. This is the AB matrix. Okay, so let me write it here. AB matrix is 5, 4, 13, and 8. Okay, now let me find what is BC. Because first we have to multiply A into B, then and in the right hand side B into C, or left hand side B. Okay, B into C, let me first find out. Secondly, I have to find out this BC now. Then we multiply by the third matrix, respectively AB to C. This AB is multiplied to C, AB into C then, and BC multiplied to A, B, C. In that way, we have to equal them. Whether that comes out to be equal, then we say that yes, associative law follows. The associative law